Alright, so we talked about permutations and the fundamental counting principle, two different ways to think about the number of things in a set or the number of ways something can happen. Recall that permutations had that order to it. It was either lining up or assigned or how can they be selected, that kind of thing. So now we're going to delve even further into that and kind of mix it up a little bit with combinations. So the first thing I have here is this little scenario. What's the difference between 1 and 2? So maybe pause the video at this point, read through the two problems, and think about what's different in the two situations to distinguish them from each other. Right, so give it a second, read them through. Alright, so now I'm assuming you paused. If you didn't, whatever. Let's talk about this. So 7 students entered into a poetry slam are awarded a personal coaching section with one of the nation's top 10 poets. So that top kind of sticks out to me. How many ways can the prizes have been awarded? So that's assuming that these are going to be the top people as well. So this tells me that it seems like order matters in this case. Because I've got prizes going on, I've got the top 10 poets, that type of thing. Scenario 2 is 7 students who entered into it are awarded one of the 10 admission tickets to the 2010 National Poetry Slam. Then how many ways can the tickets be awarded? Well, tickets is kind of ambiguous. Doesn't really seem like I know what's going on here. It just tells me that 7 students entered are awarded 10 general admission tickets. So it seems in this case that order does not matter as much. Now, that's kind of what I want you to get at here, is that we've been talking so much about lining up and ordering and stuff. So the summary that I have for you here is that when order matters, so order goes with permutations. But what happens when we don't really care about the order anymore? Well, if we don't care about the order, then when order doesn't matter, we have combinations. And again, that's the big hot ticket item of this discussion. Well, what is a combination? Well, if permutations was using P, you betcha combinations uses C. Thought you were going to say W? No. Alright, so N, choose R. Well, look at that. Didn't we use that in binomial expansion? Well, that's coming back in a second. Just hang on tight. So, NCR, or, again, you may see it C, N, comma, R in the book. Sometimes it's listed as that. Well, they're both the same thing. This is N factorial, just like P is. However, now we need N minus R factorial times R factorial. So what are all these parts? Again, number of ways of total choices over the number of chosen choices and the number of unchosen choices. So we got to figure this out by using all those different parts. So now, since we have permutations and combinations, we really got to pay attention to the wording of these different problems. So why don't you take a second, go through these, figure out if you can see if it's a combination or permutation. So look for keywords that maybe go with order mattering. Alright, so once you've done that, hopefully you have, let's go through it. So introducing 5 starting players to the basketball team. So we're introducing those players. The order does matter, so this is a permutation. So permutation, well, 5 starting players, I'm going to announce all 5 of them. So I'm going to do 5P5. Alright, that's 5 factorial which ends up giving me, what did we get from that? 5. 120. So 120 different ways or orders that you can announce that team. Checking out a list of books from the library to help you prepare. Nothing about that really tells me I need to check out these 3 books in order. So this is a combination. How many books am I checking out, or how many books total? There's 8, so that's N. I'm checking out 3, so that's R. So I've got 8, choose 3 books. Or 8 factorial over 8 minus 3 factorial times 3 factorial. Now, yes, you can figure all this out, or you can use that 8 math, probability, choose 3. Get you 56. Alright, so 56 ways or combinations. Electing 4 students from a field of 7 candidates to serve on the prom committee. Now, since they're all equal status, this is actually a combination problem. So the way I kind of figure that out is that it's just a prom committee, so equal status. Now, if it were like doing a president, a vice president, I'm getting there, it would be different. So 7 candidates total, I'm electing 4, so that's R. So 7 choose 4, or 7 factorial over 7 minus 4 factorial times 4 factorial, which is 7 factorial over 3 factorial over 4 factorial. Or, again, using 7 choose 4, you get 35. Alright, moving on here. So this is where we're talking about electing 4 to serve as president, vice president, secretary, and treasurer. So since there's a selected position, this is a permutation. So that's again, select positions. That means the order of those positions matters. So I have 12 people, and I'm electing 4, so that's R. So 12P4. Or, going back, now this is a stretch, we got 12 factorial over n minus r, so 12 minus 4 factorial. That's all it is. We don't have to take out the chosen ones here. So 12, and we're going to pick 4. We've got 11880. A lot of different ways there. Alright, now here's where things get a little bit tricky. Assigning A's, B's, and C's to students. We have multiple things going on. Now, it doesn't really matter the order I do this. So this is combinations. If I want 10 A's, well, I have to do out of 25 total people, so 25, I'm going to choose 10 A's. So again, this is for the A's. Well, what about that? Now, I've got to choose some B's. So multiply by the B's. But how many students are left now? So think about that. Well, 25 minus 10 gives me 15 students left. I'm going to choose 8 B's. Well, now, let's go over to the C's. How many C's will I choose? Well, how many students are left? 15 minus 8. Well, I'm left with 7. Choose 7. Well, 7 choose 7 is just 1. So multiply by that. So let's figure that out. We've got 25. We have to choose 10. That's 3, 2, 6, 8760 multiplied by 15, choose 8. So that's 6435. Now let's multiply that by 3268760, and we get a large number here. The reason I didn't keep continuing here, oops, sorry, this should have been in green. 6435. So that doesn't confuse you there. Times 1, because 7 choose 1 is just 1, or 7 choose 7 is just 1. And that was a total of 2.1034 times 10 to the 10th power. Now that's kind of a confusing way to think about it. Well, there's another way you can figure it out. You can do 25 factorial and divide out all the other different ways that happen. So divide out 7, 10, and 8. If you do that, you'll get there. Alright? But let's extend the idea. So that's where I'm kind of getting at here, is that we're partitioning or labeling something. So partitioning and labeling is the way that we would get that problem. So we'll collecting my thoughts. Alright, we'll go back to that problem using this idea of partitioning and labeling problem. And as you can see, we're getting back to those coefficients. So, when do we use this partitioning and labeling idea? So use when identical or undistinguishable choices. So basically that means like if things repeat, or if it says you have 6 undistinguishable floats and you have 10 cars that are all the same model, something like that, you're going to use this idea. So how do I figure out what to do here in these words? How many ways can we rearrange? Well, notice that words have repeating letters. So that's this idea of having identical choices. So we need a way to figure this out. You take the total factorial and you're going to divide out the identicals factorial. And sometimes there's multiple there. So figure out, in Roselle, I have 2 E's, and I have 2 L's. But I have a total of 1, 2, 3, 4, 5, 6, 7. 7 letters. So if I want to rearrange these words, I need 7 factorial total over the undistinguishables. So 2 factorial, 2 factorial. Alright, so figure that out. You're going to go in. You're going to do 7 factorial, and in this case, divide out. Now put parentheses around your factorials. Oops, I forgot to put in the 2. And another 2 factorial. So math, probability, factorial, close your parentheses, and you get 1,260. Alright, so let's go ahead and do isosceles. So I've got 1 I, that's okay. I have 3 S's. 3 S's. Oops, that's hard to write. 1 O, 1 C, 2 E's. Alright, how many total letters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters. So 9 factorial over 3 factorial, 2 factorial. Alright, so I'm going to let you pop that in your calculator and finish out Tennessee. Now, This can also be used to find the coefficients that we talked about before. So this is the same as labeling and partitioning, because it's that idea of having a combination. So this is a binomial. In a binomial, before we had done the whole what's the power, what are we subtracting out, that kind of thing. So before we did NCR, which was 5, and we need to know the coefficient of that. So NCR, well, I'd have to list out all the terms and try to figure it out. This isn't really viable anymore. So the way you want to go about this is think about the power, which is the total, which is 5. Then you want to take the terms. Well, these terms repeat in the phrase. So term 1 is a power of 3. Term 2 has a power of 2. So let's take this, put it all together. We get the total, 5 factorial, divide out the repetitions, and then we get our answer. So 5 factorial, again, I'm actually just going to take the second entry and edit it. So 5 factorial, divide out 3 factorial and 2 factorial. We only get 10. That's your coefficient, if you were to go ahead and figure it out, which I believe is 5 choose 2, maybe 3. This works the same exact way for doing a trinomial. So then we just got to figure out, okay, total power is 12. Divide out 3 factorial, divide out 4 factorial, divide out 5 factorial. Right? And again, you can figure that out, finish it, get the answer. Now, my last thing is a note on subsets. You have a question in your homework that's about subsets, so I want to go over those. So if given a set such as A, B, C, and D, we know that AB is the same thing as saying BA. Those are subsets. So these are subsets. But they're the same exact thing. So we don't want to count them twice or multiple times in subsets. And why am I talking about this? Because you need to figure out how many subsets this set has. So if I were to do this, if I were to just take A, B, C, D off the side and not repeat any sets, well, I have A, B, C, D. That's one set. I can do all sets of 2. A, B, A, C, A, D. Well, now I can't repeat anything. So now I have B, C, B, D, and then I have C, D. Alright, well, how many total sets is that of 2? That's 6. Now what about sets of 3? I can do A, B, C. I can do B, C, D. I can do A, C, D. And I can do A, B, D. Well, that's 4 sets. I can also do the set of A, B, C, D all alone. That's 4 sets as well. I can also choose none of them. So that's another 1 set. Well, how many total sets do I have here? Well, 10. I've got 16. Oop, I added a set here somewhere, didn't I? So basically what I'm getting at here is that you need to use combinations to figure this out. It is well, what if I take 4 terms and I'm going to choose all 4 of them? That's 1. What if I take 4 terms and I just want to choose 3? Well, that's 4. What if I take 4 terms and I want to choose only 2 of them? That's 6. 4, choose 3 of them. Back at 4, 4, choose one of them. Oh, that's my 4, sorry. 4, choose 4 is 1. 4, choose 1 is 4. 4, choose 0. That is my 1. So 4, choose 3. I missed one here. I repeated something, didn't I? I repeated 3. Whoops, my bad. I'm sorry, guys. So 4, so I got 1, 6, or 1, 4, 6, 4, 1. So 6 plus 4 is 14. At 15, 16. So there's 16 sets there. Alright, so again, the way you can figure that out is multiple ways. Another thing here is, again, this was my original set. This is where I got stuck here first. Is 16 is 2 to the 4th power. So if you take each term and you have 2 of them, basically, you're going to do 2 to the 4th equals 16. That tends to work for sets as well. Although putting all the combinations and adding them together is really the way we want you to think about them too. So that's just to talk a little bit about subsets. I know it's kind of confusing, but you don't always want to list all of the sets, so that's one way you can get there. Alright, bring it out to class tomorrow, finished up the ones that you just had to fill in some stuff, and we will go ahead from there.